Hello DU Hacks. My name is Chala Palsi and I am from Team Codestars. And here I am presenting to you Project Tarzan. We wanted to learn about autonomous driving using machine learning, right? But of course, we cannot start with the real cast. So we decided to take this opportunity of hackathon to put first baby step toward the directions. So what we have did is we have tried to simulate this autonomous driving inside the game world of GTA City. And for this, as dataset, we are using the frames and the inputs captured while a real player was playing the game. So, for example, for every 500 milliseconds, we have captured a frame and corresponding array of keys which has been pressed by the player at that time. So that consists of our data set. After that, we've fed it to a convolution neural network. So it will perform the feature extraction, and then those feature maps will be fed to artificial neural network, uh, which will eventually generate the keys that should be pressed. And we have one driver program here which is called main controller. So what this does is, while a game is running on the system, it, at every 500 milliseconds it takes a frame, captures it, feeds it to model, and then model will return the array of keys that should be pressed, and this controller will simulate the those keyboard keys being pressed. So the game will feel like a human is playing, but in fact it is this controller or the agent which is using the machine learning model to predict the keys and play the game. One of the major issues that we faced was uh, finding the data set. So we found two data set. One was very small, around 500 images in each label, and the second one was quite big. It has 17,000 images, but due to hardware limitations, I don't have a computer with a GPU, so I could not train my model on the 17,000 images. So I went with the smaller one, due to which I feel very bad to say, but the model, of course, will not perform very good on that small amount of data. So it works, but it almost certainly crashes every time. I mean, crashes the car into some wall or some other car. So I think showing you the game and the demo would be unfruitful. So I will take you through the code instead. So this is the main controller. This is the function to capture the frame. This is the function to process the frame, which is performing normalization, resizing it, and so on and so forth. This is the function that takes the frame, feeds it to model. Here, model.predict takes the predictions and returns it. And this is the main function, which at every 1 second, or we can set it to 500 milliseconds, what it does, captures the frame, get the predicted keys, and presses them for 1 second. So yeah, that's the most of it, and this is the code to train the model, which we have already done, and this generated this .keras file. So I will show you the model. So this is a CNN, which we created using the Keras sequential class, which just stacks one convolution layer, one layer on top of another. So we have three blocks of convolution layers followed by a normalization layer and a max pooling layer. Then the flatten layer, which will convert those 2D images into one single huge array, one dimensional array, and then two layers of dense networks, fully connected networks, which would eventually generate array of four, which will correspond to WASD, forward, left, backward, right directions. Uh, so that's it. Then there's loss function and accuracy. So yeah, that's pretty much it. So I regret that I could not show you working of the model. But yeah, uh, we will continue working on this, and we learned a lot actually. So I'm very happy with that. And thank you for organizing this amazing hackathon. uh, yeah, thank you. Bye.